With these two questions about graphing, right? So in the PowerPoint, it talks about reflections, okay, where the negative is with the x inside the bracket and the negative outside, right, the logarithm function. Okay, so when it says with the negative with the x inside the bracket, then it reflects it through the y-axis, right? So like the red one here, okay, compared to where the blue one is, which is a normal log 2x graph. All right, so we know that it's reflecting in this direction. We also know that it has an asymptote at 4. All right, so we know that it's an asymptote at 4. So when we draw it over here, we know that it's going to be an asymptote here. All right, now our normal log usually goes that direction, as you can tell by the blue graph. All right, but of course this is being reflected going the opposite direction, okay, through the y-axis. All right, you can just substitute points in. So for example, if I put 4 in, right, that's going to be 0, so we know it's non-existent because that's where the asymptote is. If I put something in like 1, right, so if x is 1, then I've got 4 minus 1, which is 3. Log 3 of 3 is 1. So we know that at 1, when x is 1, y is going to be 1. All right. So you can also then work out the y-intercept, or, for example, the x-intercept, okay, by letting y equals 0. Then you have log 3, 4 minus x. All right. Turn it into an exponential, so 3 to the power of 0 equals 4 minus x. You then have this is going to be 1, so 4 minus x, and of course then x has to be 3. So we know that it's going to have an x-intercept there. All right. We know one other point, which is 1, 1. We can then work out the y-intercept to let it x equal 0. So if we let x equal 0, then it's log base 3 equals 4. We can find another point, but pretty much, okay, the iPad's trying to help us out here. All right, so I'm just going to ignore that. Okay, so we know that it's going to sort of come along here, go through there, and along. All right, and then we can identify that as 0 log base 3, 4. We only have to estimate where that value is, all right? But we've got those other 2 points. Now, I could put in, what would I put in? I would put in maybe minus 5, all right? Because if I put in minus 5, right, and you've got to think, we know that it's log base 3. So anything that has a factor, so basically if I'm thinking minus 5, right, I'm thinking 9, yeah? So if I'm thinking 9, that's 3 squared. Right? So if I'm looking at minus 5, then that's going to be 2. Right? So already I know, stupid iPad. All right, already I know that the y-intercept, right, has to be less than 2. Okay, because minus 5 would give me 2. All right, so that's why my curve, and it's a pretty dodgy curve, right, that's why my curve is sort of going down that way. Right, now for this second one, right, looking at our notes, right, the negative's outside the log function, so this means it's reflecting through the x-axis, where all the y values change signs, okay? So again, like our example, like our graph that's in blue, right, that's our normal one. And then because the reflection through the x-axis happens, right, it becomes that black graph. Of course, there's a dilation in it. There's a dilation in front of, there's a number in front of the x, so we know that there's a dilation in it, right? We've got the, right, asymptote, okay, for this one. So we know that it's going to be, of course, x equaling 0, right? So that's where the asymptote is. We know from our reflection, all right, it's going to be reflected. So, of course, we try different forms of x or values of x that will give me a base that I can work with, right? Because I've got a log 3 base, right? So I have to try and find, 3 squared is 9. We know that. 3 we need to find so we can find out when y is 1. So, of course, I'm going to try x equaling 3 over 2. Because I know 2 times, or 2 divided by 2 is 1, right? Which would leave me with a log 3, 2 times 3 over 2. So then that's going to give me minus 1. Right? So when x is 3 over 2, 1.5 basically, so 1.5, then x is, y is minus 1. So I know there's a point there. What I want to know, or what I want to do, is find out, right? Now, you can have a look at this information about dilations and stuff, right? But what we already know, of course, is that it's reflected. Okay, we know it's a reflection. So again, we can then go, okay, when y equals 0 and solve, all right? Solve for x, okay? Now, if you decide to divide both sides by -1, we can do that, okay? Which still give you 0 there. So then we've got log 3 2x there. 3 to the power of 0 is 1, 2x there. All right, because we've changed it to an exponential from the log form. And then x is 1.5, okay? So we know that it's got to go through about there. All right, now I've got my 2 points. I can go like that. I can find another point if I want to, like, for example, I would then try 9 over 2. Why would I try 9 over 2? Because 2 divided by 2 is 1, all right? So just to prove to you why I would do that, if I did 9 over 2 like that, that then becomes log 3 of 9. And we know that that's 3 squared. Okay, so then it effectively becomes that, which means the 2 goes out the front with the negative. That becomes 1. So then when basically x is 4.5, because that's what it means, when x is 4.5, so up here, y is going to be -2. So we know that that's where it's going to end up going through, and it just looks a little bit easier and better when we actually graph it. All right, so we can see that it's going through there. That's how you would graph these by manual means. All right, but of course, if it wasn't, if it was on your CAS, for example, then you would just draw it out, from your CAS. All right, so hopefully that helps you.